solving Leetcode 2359 problem number, and the question is saying that find the closest node to given two nodes, right? We have to find the closest node to the given two nodes. Okay, so today we will be solving this problem, and this is a graph based problem that involves path traversal, and we will break down into some steps, and also I'll provide you the dry run for this example, so you will have the clear understanding for the implementation. So let's dive in. Let's read this question so you will have the clear understanding. So you are given a directed graph of n nodes number from 0 to n minus 1, where each node has at most one outgoing edge. Means at most each node has at most one outgoing edge, right? As you can see in the graph, right, each node has one outgoing nodes, right? This is called outgoing edge. Okay, and there is a graph. The graph is represented with given 0 index edges of size n. Means there is a edge we have given like this. You can see, right, we have given edge, and further it is saying that indicating that there is a directed edge from node I to node edges at I, right? Means from node I, right, there is a edge at I. Okay, so if you'll talk about, if we have given a node, let's suppose we have given a node like this, right? These are the nodes we have given, and 2 3 3 minus 1 we have given in the edges, right? So it is saying edges at I. Edges at I is what? It is coming from the I, right? So I see from node I to node edges at this. So there is no outgoing edge from I, and there, so we can say edges at I equal to minus 1. If there is no outgoing edge from I, then we'll say edges at I equal to minus 1. Means if there is a outgoing edge, it's fine. If no outgoing edge, will represent as minus 1. So here it was a minus 1, means there is no outgoing edge for 3, as you can see, right? But the rest of we have like coming, 1 has going to 2, 0 going to 2, 2 is going to 3, like that we have given. See, the I is going to 2, node 2. So I means what? 1. 1 is going to what? 2. 2 means 0 was coming to 2, 1 was coming to, so this is your 0 node. 0 node represent that it will go to 2. 2 is represent 1, means it goes to 2 outgoing is, and similarly 2 going to 3, means 0 1 2. So the 0 0 1 2, these are 3 nodes having the outgoing node value here, right? And 3 doesn't have any outgoing edge, so it's saying minus 1. So this is the thing it is saying, that we have given edges, right? And there is a directed edge from node I to node edge at I, right? And if there is no outgoing edge from I, then we will represent it minus 1, and so we will be representing this minus 1. I hope you understand, right? There is also two integer nodes 1 and nodes 2 we have given, right? Like this we have given here, and it is saying that return the index of the node that can be reached from both node 1 and node 2, such that the maximum between the distance from node 1 to the node to that node and from the node 2 to that node is minimized, not maximize, minimize, right? If there are multiple answers, return the node with the smallest index, and if no possible answer exists, return minus 1. And note that edges may contain cycle, right? Means if you have understood the problem statement, right, till from here to here, right, what you have understood, that you are given a directed graph with n nodes numbered from 0 to n minus 1, right? Right, see here, 0 to n minus 1 it is given, and it is also saying that each node has at most one outgoing edge. So each node has at most one outgoing edge, and the graph is represented by an array that is called what? Edges, right? And edges at I equal to j. This is the meaning. Edges at I equal to j. What is j? J means there is an edge from I to j. Gotcha? See, edges at I is what? is j. Means there is an edge from I to j, I to j, I to j, right? Means if edge at I equal to -1 means there is no edge. If edge at I is equal to -1 means there is no outgoing edge. But if there is something that is called j means there is an edge from I to j, right? This is the meaning. I hope you understand, right? You are also given two nodes apart from these things, node 1 and node 2. So your task is to find a node that is reachable from both node 1 and node 2. Understood, right? What is our task? Our task is to find the node that is reachable from node 1 and node 2. So these node 1 and node 2 is also given. And among all these nodes, we have to minimize the maximum distance from either node, right? Minimize the maximum distance. Minimize the maximum distance from either node, either node 1 or node 2. If multiple such nodes exist, return the one with the smallest index. If not exist, return -1. Sounds tricky, right? But don't worry. I'll visualize also the problem and you will understand clearly. Okay. So make your hook tight and let's dive in clearly. Okay. So what we have given? We are given a directed graph with n nodes we have given, which is 0 to n-1, and each node has at most one outgoing edge. And so we are saying that edge at I is j. It means there is an edge from I to j, right? If edge at I is equal to -1, it means I doesn't have any outgoing edge. It means no outgoing edge there. We are also given node 1 and node 2, and so our task is to find the node, right, that is reachable from both node 1 and node 2. Among all such nodes, so we have to minimize the maximum distance from either node. If multiple such node exist, we have to return 1 or return -1. Okay, but if you are going to return, we have to return the smallest index, right? We have also given an example, so let's dive into this example, right? So as you can see, we have given these edges. We have already seen the graph in the Leetcode, right? So this is the edge we have given 2 to 3 -1, and node 1 is 0, node 2 is 1, right? What does it mean is this? So this is index 0, this is 1, this is 2, this is what? 0, 1, 2, 3, right? So 0 is this index. It's having outgoing edge at 2. So we are representing 2. Then we have 0, 1. So this 1 is representing 2, right? And if you talk about the 2, 0, 1, 2, 2 is what? 3. And so this represents 3, right? 3 doesn't go into the next node, right? It doesn't have any node, so it is having -1. Okay, I hope you understand this way, right? So you can represent 0, 1, 2, 1, 2, 3 like this. You can represent. Let's trace the distance from both node 1 and node 2, so you will understand. Just think that from node 1 we have 0. So if we will write 0, 2 and 3, the first one that we are talking about, 0 to 3. If from node 1 means node 1 is 0, 0 to 3. So the distance is what? From 0 to 2 is 0 to 1, and from 2 to 3 is 1 to 2. So 0, 1, 2, right? From distance 1 we will compute, right? Similarly, we can say node 2 means 1. We can say 1, 2, 3. We have seen, right? We have already seen this. Means from node 0, we can say this graph, and the distance is like 0, 1, 2. If you call for distance, will calculate from the node 2 is 1, means 1, 2, 3, and the distance is 0, 1, 2, right? So we have now from node 1 and node 2, what we can say that 0, -1, 1 and 2, and from node 2 we'll say -1, 0, 1, 1, 2. So like this we can represent this, right, from node 1 and node 2. Okay, so these two are the distances from the node 1 and node 2. Now we will find all the reachables from both and we'll compute. How? We'll find the max. So we have already calculated the distance at I and distance at distance to at I, right? So if you have both, right, what you will do, you will find the max one. Which one is the max? That you will count. So for the max 1 and 1, you will get 1. From max node 3, you will get the max 2 and 2. Means we will ignore these two because this is not the smallest max. This is the bigger one, right? So node 2 will select, right, that the smallest max distance we have, and so we will return 2. Understand, right? Each node, it will points to at most one other nodes. So it we have like a linked path. From any starting node, we can simulate the traversal and will record the distances to all the reachable nodes, right? That we have already seen. And so we will do traverse from node 1 and will record the distance. We'll traverse from the node 2, will record the distance. So we have to record the distance. And after that, we'll compare all the nodes that is reachable from both, and then we'll pick one where the max distance at 1 and distance at 2 is minimized, right? Which one is minimized, that we will take. Understood, right? Let's go to the Leetcode and understand the code. So the problem was given here, right, as you have seen already, right? So the we have given a directed graph, right, as you can see here, right? We have given a directed graph where each node points to at most one other node, and we have two starting nodes. We have also given node 1 and node 2, you can see, right? We have given, and our goal is to find the node that is reachable from both node 1 and node 2 such that maximum distance from either node to it is minimized, right? So if the multiple such node exist, we will return the node 1 with the smallest index, right? That we are going to see. Means if you talk about what is the approach, right? So we will go with the very two simple steps, right? But I have written a couple of steps here, so don't worry with that. Very easy step will be there, that first of all we will for each of the two nodes, right? We have given these two nodes, right? So for each of these two nodes, we will calculate the distance to every other node using the DFS or BFS. You select whatever you want, right? Either DFS or BFS. Then for each node I, if I is reachable from both node 1 and node 2, we will compute the max, right? Means distance from node 1 and distance from node 2 that we have seen, right? So we'll compute that, and then we'll keep track of the node with the minimum of these max distances, right? So very two simple easy steps we have, and we have to do that. Let's suppose if we have given edges, we can find the number of nodes, right? And then we will find the distance. How we are going to find the distance? Means that get the distance from node 1 and node 2 to all the reachable nodes, right? And to do that, you will call this helper method, get distance. You will pass the s node 1 and number of nodes, s node 2 number of nodes, right? You will find, and you will have the distance from node 1 and node 2 you will have, right? It means the distance from node 1 and 2 to all the reachable nodes you have calculated. Gotcha, right? Means for each of these two nodes, we will calculate the distance to every other node using DFS or BFS, that we will see. Okay. Now what we will do, we will initialize the result. Now we will initialize the resulting variables because we need these variables, right? So first of all, we have the resulting node that will give you the smallest index, right? And so we'll take -1. We'll take the minimum distance, and if we want to find the minimum distance, we have to take some infinity value. So we'll take integer or max value, and so we will find the mean value, right? So if the mean value will come in this loop, we'll update this mean value and we'll discard the max value. Now what we will do, we'll make a loop and we'll go through all the nodes and we'll find the one with the minimum max distance. So all the nodes we have given, so we'll traverse for all the nodes. Means 0 1 2 3, these nodes we will traverse, and then we'll find the if distance is not -1 and distance at 2 is not -1, means both we have already calculated. We will only consider the nodes reachable from both node 1 and 2. So both node have, right? And so we'll find the max one. Which is the max? We'll store the max distance, right? Now we'll check the distance, resulting distance, right? If the minimum distance is greater than the max distance that we have calculated, means we will update the mean max distance with the max distance, right? And you will have result equal to minus not -1, not -1 will update its latest index, right? And so this index is nothing but the smallest index for now, right? And finally we'll return here the resulting node, right? It means it will keep updated for all the nodes. It will traverse for all the nodes. This is the for the first node that we are talking about from the 0, but it will talk from 0, then it will go from 1 for 2 and then 3, like that it will go, and it will keep updating the node index, right? Means the smallest index we will find at the last. We will traversing you, once you will traverse all the nodes, right, you will have the resulting node, and then finally we'll return it. And we know that we have to create another method, that is method this, right? So first of all we will define the distance array and you will return this at the last once you will calculate it. So initially we will fill with the -1, means we will mark all the distances as unreachable. If you will find the -1 means unreachable, right? There is no path we have initially, we can say like that, right? It is unreachable. And so we'll take the current will start from the start, means the first node will start from here, and then we'll have the distance. So we'll traverse through the while loop. Current distance at current, if it is equal to -1, means this is the initial value, right? And we'll also check the current node should not have the -1. If current node is -1, it means we are talking about this node, right? So we'll not go for that node, means current node should have some value. So we'll keep updating the current dist at current, and we'll update the distance plus plus, right? And similarly we'll have the current, right? So current will update from what is at current, so you will get the current. Means we want to set the distance to the current node, and then we will move to the next node, right? Will explain in the dry run steps, don't worry. And then we'll return the distance, like this we will do. Okay, means first of all what we need to do, we will initialize the distance array, right? First of all we'll initialize the distance array, right? Why we will do that? Because we will create two dist arrays, right? Dist1 and dist2, we can say we'll create, and for each of the size we'll have n, and so we are passing the n, right? So once you will pass the n, you will create the distance array, means this will initialize the both array distance1 and distance2 with the size n, and it will store the distances from node 1 and node 2. So node 1 will be here and node 2 will be here, right? Means it will keep moving ahead, and it will find the distance from node 1 and node 2 for every other nodes. And if all the elements are initially set to -1, right, as you can see here, right, it means it is unreachable, right? And once you will traverse the path from the starting node, and if this condition satisfy, means if current is not at -1, means this is not unreachable, means it is reachable. And so the initial distance will be -1, means we have not calculated it, and then we'll update the dist at current, means there will be some distance will be there, right? And so keep we will set this value, and then we'll update the current like this. It will keep iterating this, and it will find the all the distances, means from the all the nodes value will update the distance, right? The distance from all the distance from the node to all the nodes, right? We will find it, right? Then this distance will get the distance from the node 1 and node 2 using this helper method, like this we will do. So this method is called get distances. We will call this for traversal along the edge, right? Edge array, we can say, and we will keep traversing this. At each step we will move ahead. How? Edge at current, right? And we will increment the distance at a time, +1, we will do +1, okay? And we will stop if the current node is -1. Once the node will come to current is -1, means there is no outgoing edge is there, and we have already visited it, right? So we have already visited with the node to avoid the cycle, right? Like that, we'll keep checking. So initially that is why we have marked it, okay? And once this is done, then what we need to do, we have to find the closest meeting node, right? And for that, how we are going to do, you will have to traverse the this one, right? Means from 0 to n minus 1, we'll make a loop, right? We will go through all the nodes I from 0 to n minus 1, and if the node is reachable from both node 1 and node 2, you will compute the max distance, right? Once you will calculate the max distance, right, means from means the node is reachable from both node 1 and node 2, and we have find the max distance between them, right? Now now it's time to track the smallest of these values, and will return the node with the smallest, and so that finally we'll return it, and we'll keep updating this max distance thing, right? I hope you understand. Let's go through the dry run, right? So initially we have given this example that we are seeing. So let's suppose we are taking here as well, right? So how we are going to implement, how we have implemented this, and will it work or not, right? So let's do dry run. Let's understand, if we will represent these edges, right, then we can say that index 0, this is index 0, this is 1, this is 2, this is 3, right? 1 0 1 2 3. So 0 1 2 and 3. So 0 having one outgoing edge for the 2, as you can see here, 0 having outgoing edge is 2. Similarly, 1 having outgoing edge is 2, right? Then we have node 2, it is outgoing having one node is 3, and similarly 3 doesn't have any outgoing edge, and so it represent -1, as you can see here, right? Or you can see here, okay? Like this we can represent. If we will represent like this, so we can also represent like this, like 0 pointing to 2 and 2 pointing to 3, means 0 pointing to 2 and 2 pointing to 3. So we can say that, right? Further, there is no outgoing edge, so we can leave it. Then another node is 1 to 2. So there is 1 to 2, and 2 is already 3. So we can represent these two. Okay. Means there is true approach that we can represent this in the graph like this. Okay. Or in a single graph, if you want to try, you can try like this, right? Now it's time to find the distance, right? So distance from node 0, means from node 0 we will find like this, right? These are the reachable nodes are there, right? So if we will start from the node 0, what will happen? We will initialize the distance 1. How we are going to define the distance 1? So distance 1 will become what? First node will be -1, -1, -1, -1. So all these nodes are initialized. We have initialized like that, we have told, right? So we will initialize all this as a -1, right? So we'll calculate and we'll define the -1 here. And so from current is 0. Let's suppose current is 0 here, this node. So dist at 0 is 0, will mark, right? Then we'll check current is at what? Is at 0, which is 2, right? We are current is at 2. So distance at 2 become 1. We will do plus plus, right? We will update the, because previously the current was what? Current was some value was there, right? It was not -1 now, but we have updated this distance here, right? So previously it, because we have started the distance 0, now we have to plus plus, and then we will updating this value, right? So we will update the current and distance too. So will the distance will become what? 1. Similarly, from the current, distance is 2, its value is 3, means dist at 3, now it's become 2, means from 0 to 1 is 1, and 1 to 0 to 3 it become what? 2. So total the distance we are updating is at 2, it at distance at 0 means itself, means we are talking about itself, right? Distance at this index is 0 for the, we are talking about for this one, right? This one. So at 0 is 0, at 2 is 1, at 3 is 2. So we have done these 3 steps, right? Now we'll find the current one, right? So current at 3 is -1, so we'll stop it. We will not go further because there is no further next point, next node is not there, and so we'll stop it here. So if you'll talk about the distance, final distance will look like this is the index 0, 1, 2, 3, right? So at 0, we have calculated 0 index, 0 distance. At 1, we have what? -1, right? Then we are not, we don't have 1 in this graph, right? And so we'll say that. Okay, let me write here so we'll not get confused. Okay, so these are the nodes, you can say like this we have, and the value is like this, right? We can say. Okay, similarly we'll do for the distance 2, right? And you will have the distance like this, only distance at 0, because we know that the distance we have is, let me copy this here, like this, right? So for 1, we don't have 1 here, so we'll mark it as a -1. Rest will become 0, 1, 2, right? Like this will become. Now it's time to compare the nodes and find the max one, right? So how we are going to find? Just traverse for all 0 to 3. You know that you have the distance is now you already have, right? And both distance 1 and distance 2, we are not having -1. So for each node I is 0 to 3, if reachable from both, distance 1 is not -1, distance 2 is not -1, right? Then we will say this is reachable, right? And we will calculate these things, right? We have seen in the code, right? We have find the max one, right? Which one is the max? That we will compute. Let's find for all. First loop is for loop. We have, see, we are talking about this loop, this for loop. Okay, now we are at here. So we will compute this for loop, right? So this for loop will start from what? 0 is equal I equal to 0, right? The first node contains some distance, that is 0, and distance at 2 we don't have anything, will return -1, right? Distance 1 is this one, and distance 2 is this one, right? And these are the values we have given. Okay, so now we'll calculate like this. So if you observe that these are the values you have in the distance. So if -1 is coming, we'll skip it. If 0 is coming, we'll skip it, right? It means there will some value will be there, right? So we'll select this one, because distance at 1, distance 1 at 2 is 1, distance 2 at 2 is 1. If you'll find the max will come 1, right? And then we have I equal to 3, means node 3 we are talking about, last node. So we have 2 and it's also having 2, right? So the max will become 2. So we will ignore this, right? Because this is the max one, right? And we will select the minimum one, right? As you can see in the example, it is saying that where is that? Return the index of the node that can be reached from both node 1 and node 2, such that the maximum between the distance from node 1 to the node to that node and from node 2 to that node is minimized. If it is maximized, you will choose this one, right? You will choose this one, or you can finally say you can ignore it, right? For now, the current best is node at 2, and so our answer will become for this, and the max distance is what? 1. So node 3 has a greater distance, that is 2, and so we ignore it, and the final result is what? Will return node 2, and so you see the 2 we are returning, right? As you can see, the distance from node 0 node 2 is 1, and from distance this one is 2 is 1, and so the maximum distance between the distance is 1. It can be proven that we cannot get the node with a smaller maximum distance, will return 1, so will return 2, right? I hope you understand. Let me know in the comment box, guys. Okay, so let's summarize this one, right? So first of all, we'll initialize the distance array. We'll create two distance array, distance 1 and distance 2, right? And we'll store the distance from node 1 and node 2, right, to all other nodes, and we'll fill them with the -1, that is, we say as a unreachable initially. If it is -1, it means it will represent like that this is a unreachable nodes, and then we'll keep track of we can say we'll traverse for each nodes, right? We will traverse from each node. We'll use this loop. This is not the recursion loop, this is a simple loop to walk through the graph, and from a starting node, right, we have some starting node. from all the nodes will go, right, and we'll like node 1 and node 2 will go separately, and we'll mark them as a visited node, and we'll record the distance finally, right. Once we have recorded the distance here, right, we will return this finally, and we'll mark the visited road visited nodes, and we'll record in the distance and distance 1 and distance 2 that we have seen here, right. So distance 1 and distance 2 we have marked it. Now what we will do, we'll compare the distances for all the nodes. So for every node, right, we'll go for I 0 to n minus 1, means for every node I, right, here we'll check if it is reachable from both node 1 and node 2, right. We'll compute the max distance, right. So we'll compute the max of distance at I, distance 1 at I and distance at I2, right. We'll represent this, right, from these two, which one is maximum, we'll store here, and we'll track the minimum distance, right. As you can see, we'll check the condition. If it is minimum, if it is greater than this, then this will represent that minimum will take, right. We'll track the minimum maximum distance, right, among all the valid nodes, and we'll track the one with the smallest maximum distance. And once you will find the smallest index, smallest minimum one, right, there is a tie, we'll choose the node with the smallest index, and so we'll update this one. So this is your smallest index, and finally you will return it. If no common nodes is found, we'll return as -1, otherwise we'll return the best node that we have found here, right. I hope you understand, guys. Let me know in the comment box that you understood, and please keep watching, keep coding, and keep digging. Thank you guys, thank you for watching this video.